Section 6-1, Graphing Quadratic Equations. Here you'll notice some vocabulary terms that you'll need to be familiar with. Quadratic functions, which have a parabolic shape. The terms in a quadratic function are the quadratic term, the linear term, and the constant term. The axis of symmetry is a line that divides the parabola into two equal parts that match exactly if folded over each other. The vertex is where the axis of symmetry meets the parabola. And the y-coordinate of the vertex is the maximum value or the minimum value obtained for this function. Here we're going to look at graphing. This is a pretty straightforward process. We have a function f of x equals x squared plus 3x minus 1. We'll choose some values for x and place them in a table. You're going to see in the next example a way to best choose those values, but here's an example of some values that we could put in which yield some ordered pairs. We graph those ordered pairs and then connect them as a parabola. Here in example 2, we're going to consider the quadratic function f of x equals 2 minus 4x plus x squared. We need to find the y-intercept of this function, the equation of the axis of symmetry, and the x-coordinate of the vertex. We're going to begin by rearranging this quadratic in descending order so that we can identify the a, b, and c. Once we know that, we can identify that the y-intercept is 2. Remember that at the y-intercept, or the location where the graph crosses the y-axis, x is 0. So if we place x as 0 into our function, it gives us 2. We can find the equation of the axis of symmetry using a and b with this formula. X equals the opposite, or negative, b over 2a. Now notice here our b was negative 4. We didn't drop that negative at the front of our formula. We have a negative in front of our formula and a negative 4b, or that is b, and 2 times 1, which was our a, in the denominator. When we simplify this, we get an equation x equals 2. So now we can notice that the y-intercept is 2, the equation of the axis of symmetry is x equals 2, therefore the x-coordinate of the vertex is 2. Remember that axis of symmetry crosses the parabola at the vertex. Now we're going to make a table of values. Here's where that fine-tuning of the choice of x's to put into our table comes in. If we know what the vertex is, or the x value of the vertex, we can choose integers that fall on either side, or less than or greater than our vertex. And it's great to pick 2 values on either side. That's probably the best way to do that. You could certainly choose more. So here you'll see the table. And then we'll use that information to graph. Again, plotting the points and connecting into the curve. So I apologize, my dog is barking in the background. All right, so let's keep going. As a check, we could draw in that axis of symmetry, and that way we can see that in fact our curve has that symmetric look on both sides of the line. So then we'll consider the function f of x equals negative x squared plus 2x plus 3. We'll determine whether the function has a maximum or minimum value. To do that, we're going to identify our a, b, and c again, and all we need to know is our a. If the a is less than 0, the graph opens down and the function has a maximum. If the a is greater than 0, then the graph opens up and it has a minimum value. Here we're going to find that maximum or minimum. It happens to be the y-coordinate of the vertex. So remember, we know how to find the x-coordinate using that formula, negative b over 2a. So we use our a and b here, and we come up with the x-coordinate of 1. Then we use that x-coordinate to replace back into our original function. So here we've replaced the x's with 1, and that yields our y value of 4. So the maximum value of the function is 4. Section 6-2 has us solving quadratic equations by graphing. Here are 3 pictures that demonstrate the different types of solutions. We can either have 2 real solutions or roots where the parabola crosses the x-axis in 2 places. We can have 1 real root where the vertex lies on the x-axis, or we can have no real roots. I don't really like that it says no solutions. It really should say no real solutions. All right, so here we're going to solve x squared minus 3x minus 4 equals 0 by graphing. Just like before, we'll use that axis of symmetry that allows us to choose points on either side to fill into our table of values. You'll notice that I didn't put the 3/2 into my table of values. It's a fraction, so I chose to stick with whole numbers. That just makes graphing a little bit easier, but I chose points that fell on either side of 3/2. I then graph those points and the curve. And from the graph, we can see that the zeros, or the solutions, are at -1 and 4, the x values, where it crosses the x-axis. We could also have seen that in the table. You'll notice if you look back at your table, we had values of -1 that yielded 0 for y, and 4 that yielded 0 for y. So we can check the solutions. We really wouldn't need to in this particular case because we already had it in our table of values, but let's just look again. If we put in the -1, we in fact get 0, and if we put in the 4, again we get 0. All right, we're going to solve x squared minus 4x equals -4 by graphing. The first thing we need to do is write that equation in the correct form and follow the same steps we've had before. Now here you'll notice that this is the type of graph that touches the x-axis only once. So it has only one x-intercept, which is 2. Again, you could have noticed in the table that when we put 2 into our table, we got 0 as our y. It might be helpful to go ahead and graph, at least on your graphing calculator, just to double check and make sure. But we're pretty sure because we know that that's the vertex. So you could argue you wouldn't even have to do that. All right, here we're going to solve x squared minus 6x plus 3 equals 0 by graphing. If we can't find exact roots, either through our table or through the graph, we need to state which consecutive integers our values will be between. So again, just as before, we'll find that axis of symmetry. In this case, it's 3. We'll find values that fall on either side of 3, and you'll notice here we don't have any y's that are 0. So far we have not found those points for which it crosses the x-axis. But we can notice by looking at the y's, you can see the symmetry, the -6 in the center, going out from that in both directions, -5, -2, and +3. So we definitely can see that this will cross the x-axis, seeing that the y's go from negative to positives, but we don't yet know that exact value. So we'll look at the graph. You'll notice here that on our graph, it crosses in between values on our grid. So you'll notice that to the left-hand side of the curve, our root or our solution falls between 0 and 1 on the x-axis. To the right of the curve or on the curve, we see that our other solution falls between 5 and 6 on the x-axis. So one solution is between 0 and 1 and the other is between 5 and 6. Here are some of those classwork problems that we looked at in class, so you can check your answers.